In the STEAM lab, the team tests a strange antenna that looks like a glowing drum full of tiny blue lights.
Wait! The antenna didn't move!
Then why did the signal turn?
Excellent communication, Mystery. Something moved, but not the metal.
The team tests a strange antenna that looks like a glowing drum full of tiny blue lights. Leo immediately gives a giant theory involving space waves, invisible steering, and possibly cosmic dolphins.
Clearly, the electromagnetic wavelength is bending through a multi-dimensional resonance corridor.
Mia listens carefully, then asks the simplest engineering question.
Or, did you check which antenna dots lit up first? As a dolphin, I support communication. As a scientist, I support checking the dots.
The team makes predictions. If the antenna does not physically rotate, then maybe the tiny antenna elements are working together like a team. But how can timing change direction?
Prediction 1. The signal follows the brightest antenna dot.
Prediction 2, the dots turn on in a timed pattern.
Prediction 3. Echo is secretly pushing the wave with dolphin mind power.
That is flattering, testable, and almost certainly wrong.
But how can timing change direction? Echo explains the first clue. A phased array is made of many small antenna elements. Each one sends out a wave. When waves line up, they combine and become stronger in a chosen direction.
Imagine each antenna dot is one student in a stadium wave.
If everyone moves at the same time, the wave goes straight out.
Correct. But if each person starts a tiny bit later, the wave leans.
The team starts with all antenna elements pulsing together. The signal becomes strongest straight ahead because the waves arrive in step in that direction.
All dots fire together.
The strongest signal is straight ahead.
That is constructive interference. The waves are helping each other.
Next, the team adds tiny timing delays. The left antenna dot fires first, then the next, then the next. The wave front tilts, and the strongest beam points to the side.
The antenna still didn't turn.
But the beam did. That is beam steering. The timing changed the direction.
The team tries to steer the beam farther, but the signal becomes weak and messy. Something is wrong. The antenna elements are communicating, but not in the correct timing order.
Why do we have two beams?
Because our timing pattern is scrambled. When communication loses coordination, the message gets muddy.
Echo introduces the keyword phase. Phase means where a wave is in its cycle. If one wave starts a little later, its phase is shifted. Phased arrays use controlled phase shifts to aim the beam.
Phase is timing inside a repeating wave.
So phase shift means one wave starts a little later?
Exactly. Tiny delays create big direction control.
Now the mystery is solved. A phased array antenna does not need to spin like an old radar dish. It steers its beam electronically by adjusting the timing of many smaller antenna elements. The team connects the idea to real systems. Phased arrays are used in radar, satellites, aircraft, weather sensing, radio astronomy, and advanced wireless communication because they can aim beams quickly without heavy moving parts.
So this helps radar look in different directions fast? Yes. And communication systems can aim energy where it is needed? Exactly. Better aim means better signal.
Jada decides to retest her earlier theory. The team confirms that Echo is not steering the beam with Dolphin mind power. Though Echo is very proud of his Communica.
Nope. Phase control.
Final test. Dolphin mind power? Cool.
My mind power is mostly used for snacks and clear communication.
The team learns that a phased array antenna is like a well-coordinated team. Each small antenna element sends a wave. By changing the timing, the waves add together in one direction and steer the beam without moving the antenna.
So the antenna didn't move, the timing moved the beam. The waves communicated better than we did during the first experiment. That is why communication is not just talking. It is timing, teamwork, and clarity.
A phased array antenna is made of many small antenna elements. Each element sends out a wave. When the waves are timed correctly, they add together in one direction and make a strong signal. By changing the tiny delays between elements, engineers can steer the beam electronically without rotating the antenna. A phased array is like students doing a stadium wave.
Echo.
If everyone moves at once, the wave goes straight. If each person moves a little later than the person beside them, the wave appears to travel in a new direction.